Okay, so can you do like a 1 minute intro and then we can get going?
Yeah. Hey, I'm prepping for my interview that I have on Thursdays, trying to get in some more reps. I'm a fourth year and it's for new grad. Yeah.
Okay. Oh, so you haven't graduated yet?
Nah, yeah, I haven't graduated yet.
Okay, but I think
Yeah.
for like if you apply for new grad, you can like defer your start or something, right? Until you graduate. That's how it works,
So it's
basically.
like like early career. It's meant for people who are like graduating this year or who have already graduated, who are graduating in May or who have already graduated in the past year. I think that's the time frame for this one.
Okay, yeah, yeah. I think that's
Yeah.
pretty common, and then they basically just like decline all of their apps. So it's supposed to be for like only early career people, and then you just I think you pick when next year you start. Like I think when I looked at that stuff for like TikTok, they had you say like when can you start, like spring or like summer or
Yeah,
whatever. Is the same
I
thing.
think they base it off your graduation date and also like the team too. It's team dependent, like whether a team they put you on or a team you get matched with. So
Okay, cool.
yeah,
All right, so let's get started. So I'm gonna give you one question here, and I'll give you the function signature or yeah, I'll give you the function signature as well. Then you can feel free to ask me any questions.
got it. Okay.
Okay, go ahead.
All right. Given a string as an array of string words, you should add a close pair of bow tags and then to wrap the substrings in S. That's the small words. Overlap, you should wrap them together with only one pair of close. And they're adding bow tags. Let me just go through examples to try to see. Let me see. Okay, so just to like clarify the question. Uh, so I am so given a string and a list of strings. I need to put those words that are in the string like surrounded by bold characters, correct?
So, given a, can you repeat that?
So yeah, so given a string and a list of strings of words,
Hmm.
I need I need to go into that string and put bold brackets or whatever around those words in that string.
Yes.
Okay. And then it says okay, I think it was also said something about if two substrings overlap, you should wrap them together with only one pair of closed bow tags. Figured you should combine them. Okay. That's also important too. I'm gonna bring that down here
Mhm.
so I don't forget. Okay. Um let's see. I'm just go this example and try to like find like a pattern or something. Let's see, okay, A, B, C. So we have words. Um, so for this first example, I have this string and then these words. So we have to find the word. Put that, okay. All right. String words, strings as follows. We add for substring. Okay. I guess right now, like my like first thought is that like these like the the words in the string, like they have to be like contiguous, of course. Like I can't just say like I can't just look for the starting or like the ending like part of that string. I'm trying to see like what type of data structure I would use for this.
Sure.
Let's see. Okay. Um let's be maybe okay. BC exponent. So I mean like the first thing I like thought about like is maybe actually no. Let me see. Okay. So an approach that I thought about right now is that let me just bring this down here so I can reference it. Um, so like let's say we're like iterating through this through the string. We have like a var that's like I guess like the current the current oh wait, let me actually also ask some possible education secrets. I just thought of doing while I think of this. Um, are all the words in the list of words like are they all valid words inside the string?
What do you mean by valid words? Like, are they all
I
in
mean,
there?
yeah, are they all in there?
Not necessarily.
Okay, okay. So not all words are in strings. Okay, all right. Okay, so yeah, back to what I was and if also uh if word is empty, I'm assuming we just return the original string.
Hmm.
Okay, string. Okay. Um, so I guess what I guess going back to with this variable that holds like the current current like substring. Um, so let's say we start at index 0, we get like a, and then we move on, and then we check like if that's inside words. Um, but I guess to make that more quicker, like to check if that substring is in words, you'd have to like iterate through the whole thing. So maybe like turning this into a set. So we can do like old one lookup time. So you see if like if we do like if a is in uh words, then we would okay, I'm trying to think. Okay, yeah. So if a is in words, we check, and if it's not, we just continue adding. So then check if AB is in substring. If it's not, then and we continue. And then if ABC is in substring, we have like a like our result string, and then we can add like the closing like add the closing in the like the opening and closing bracket around this in the open string. Um, and then also like I'm trying to see too because if you move on to so let's say we have like so far our res is um b yes slowly okay okay and then we check if XYZ. Yeah, I'm seeing an issue here too because if like this if we continue at ABC, let's say we start a new subarray at X, Y, and Z. X, Y, and Z is not in this is not in words. So that wouldn't work because it just extend XYZ to like XYZ 1, 2, 3.
Hmm.
And then that would just break. So no, that would not work. So maybe I guess instead of looking, trying to remember, maybe instead of looking in uh, it's not very fast. I'm trying to think of a data structure that would do this. 'Cause I also thought about maybe doing like the opposite way and seeing if ABC is like if each word is inside the string. And then if it is, I would add the closing and like opening and closing bracket.
Okay.
Um,
Yeah, maybe let's not focus on the like, because I don't think you can. Maybe there's some like crazy like this problem. You can have some crazy efficient stuff, but let's just focus on like a working solution that's not like too slow. That makes sense to you?
okay, all right. So it can't be too no crazy. Hold one. Okay,
Yeah, you
got you.
can't have like two to the n or something, but something
Yeah.
reasonable. is fine.
Okay.
And then we can see maybe if we can optimize some parts later.
Okay. Um, let's see. Then yeah, so like I guess what I was saying earlier, I mean, with the second approach, instead of doing it like I could iterate throughout the word and see if that word is in there. And then
Mm-hmm.
if it is, I have to find it and add the brackets, but I also have to let me see, keep track of. Okay. All right, let me try to okay, let's see. So I'm starting out words, I'm iterating through words. I would see if ABC is in there. And if it's in there, I'd have to um oh, actually I think I thought of something that might work. Um
Sure.
okay. So we're iterating through the elements in words. We check if words is inside that string. If it is inside that string, we can keep it in like a variable, like let's say in like inside string, inside string. And let's say, yes, this is could this is inside that string. Like it could be like a set or a list or something. It doesn't really matter because like an indexes.
Okay.
So and then we would like I guess this also covers the case if like one of the words is not inside input s. So then we would go to like 1 2 3 and see if 1 2 3 is inside 1 2 if 1 2 3 is inside the string.
Mm-hmm.
Okay. So let's say now we have 1 2 3 inside this. So once we have like what words are inside the string, we could iterate over string, um, iterate over string, and find like uh those subarrays, or those not subarrays, but those contiguous like those contiguous like subarrays, if they're like so basically trying to find like the word inside string into there, and then you would add it to the like result. And I just iterate and look for ABC in a string. I'll also look for 1 2 3, and then I could do like the other stuff at the end where I am checking if they're overlapping or not, and then if they are, I can um, uh, edit that. If that makes sense.
Okay, so basically you're saying you're gonna have like a set of words and you're gonna check like these are all the words that I found.
Yeah,
And then you're gonna like do what with them? Like find where they are and then bold them?
yeah.
Okay, and then what if they are overlapping or like two or three are overlapping? How do we handle that?
Okay.
Like if it was this case or whatever, right? Like there can be multiple overlaps or it can even be like this is like not overlapping, this is just right next to each other, but this should all be bolded. But they can also be overlapping, right? I can have like instead of XYZ, I can have like C like BCX or something.
Yeah.
So we need to be
Okay.
able to handle those cases where like words are right next to each other and words are partially overlapping. And the other thing is, so you didn't ask, but you can have a word in here like a bunch. It's not necessarily once. So those are kind of
Wait.
like the things we
Wait.
need to handle.
Can you say that again?
Yeah, so word inner words can be in the string multiple times.
It said words and word can be in a string multiple times. Also, it sounds like
Yeah, so I
ABC.
can have like
Sorry.
ABC over here as well, you know.
Okay.
Like
Okay. I
basically the
see.
words are just target words we need to bold, but they can appear multiple times.
Multiple times.
And they actually showed that in example 2.
Two
Yeah, they show that in example 2 where like you're looking for a B and it appears multiple times.
times a B. Okay.
So I think example 2 covers most of those cases where like the A's overlap and then the B's appear multiple times and they're right next to the A, so then the whole thing should be bolded.
Got you. Okay. Um, see. Yeah, so this wouldn't work. I'm trying to think of like a dish which I could probably use, like
Mhm.
keep track. Like I don't know if like if a stack would be like would be huh. Let me see. Could I possibly use a stack here? But how would I if I could, how would I even use it? Let me see. Uh, Um let's say I put no, but if I use a stack, I have to keep track of like the words.
Okay, so I can give you like a small hint. So like right now you're trying to find words and like combine them in some way. But what if we instead like for the words it's going to be, I mean you could make them and combine them. But what if instead for every character we just say like is it bolded and not bolded? And then whenever we find sections we need to bold, we can just mark those characters bolded. That way if we mark them like multiple times it doesn't really matter. Does
Hmm.
that help at all? So like
Uh
so I can basically show you is like, let's say for like this string, we just have like so we start off as like everything not bolded, and then we can just mark characters bolded and not bolded, and then from there we can do stuff. So maybe like this needs to be bolded, 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 and like from here we can build an output. Or maybe it was like this makes it easier to like uh, figure out than
okay.
how I could bold stuff because I basically just bold things that are next to each other.
Okay. I see what you're saying. So you're saying that like I would like then I guess like how to check if so I'm saying I'm going through the string and seeing like what like when it's reloaded
Yeah, you
and
were
how
mentioning like you can find words in the string, and then when you find words in the string, you can just like mark those things as need to be bolded. And then from afterwards, you'll have this like character result. Um, and then you can like do stuff with it, right? Like you can know like, okay, the first character needs to get bolded, the second one doesn't, and so on. Like from here, it's you basically can just say like, then I know I need to bold the first chunk, and then the next chunk is not bolded, and then this is bolded, and so on, right? Like it's pretty straightforward to turn a array of trues and falses into bolded chunks because all the chunks are right next to each other already. You don't have to do any of these like word combination things that you were trying to do.
yeah, okay, I see. Okay. So that means I'd be iterating through words and then I would check. I guess it's like so character wait, character so is this list like it's like the list of the string, correct?
Well, you have a string, and then you can just make another data structure. Like you were asking, what data structure can I use? You can just make another list of like booleans that's just the same length as a string. That's just like, does this character need to get bolded? And then, for
Oh, so,
example, like let's say you find AA in the string, like here, then you'll just mark those characters as needed to be bolded. And then you find it in like all the spots wherever it is, mark that as needed to be bolded. And then for the next word, find all that in the string and mark all that as need to be bolded. And then you have this like nicely formatted um, character array. And then from there, you can just bold stuff because all the things are already like combined, right? You basically just combine chunks at that point. So you have like true, true, false, true, true. And then the trues need to be bolded. So it'd be like bold tag here, bold tag here, right?
okay. I guess yeah, with like with that approach, I'm trying to think of um like how I would know like I guess like the whole like where to mark true and like true and false so let's I guess where I'm confused is like
Mm-hmm.
I have AA and then let's say I find AA like right here like
Mm-hmm.
I would have to know like what indexes to
Yeah, I mean, you basically have to take every word and find every different spot it's in. So it would be like the first two, the next two, and then the last two, and then you'd mark all those as bold. So basically, what it would look like is like starts off like this, you'd find it'd be like, okay, the first two are AA, so I'll mark that. And then the second and third are also AA, so I'll mark that. This one's already marked, so I'll just mark this. And then the second and the third are, or actually, sorry, no, that's actually correct. Yeah. So the first time you find it is the first two characters, you'll mark those as true. The next time you find it as the last two characters, you mark those as true. And then for B, so it looks like there's six actually. So for B, you'll say, okay, there's a B in the first character, there's a B in the second character, there's a B in the third character. So if you find the string multiple times, you can just like every time you find it, mark that whole section as true.
Okay, I see.
So it's
Okay,
basically
I
like
see.
given a string, find all the places where a substring occurs, and then all those places mark as true.
Okay. So basically, then like I'm thinking that I would have to check like uh every substring, um, and this like state if there are true or false in the character list. But I think that'd be like n squared because I'd be checking every
So if you have a word that's like length, uh,
oops. Where's
if
it
you have a word that's length n and a string of length m, what's the time complexity figuring out like all the different places where the word occurs in the string, like just one word?
Would you please repeat that?
Yeah. So if okay, let's have a word of length w and have a string of
Yeah.
length s. What's the time complexity figuring out all the locations where the word is it occurs? Just the one word.
Would be like um it'd be like if that word's like if that word is like all in the string s like it makes I guess length of would be s.
So it would actually be s times w because like let's say my word is like AA. I need to start at the first index and see is this a match, and then I'd start
Mhm.
here and see if this is a match, then here, then here, then here. So at every index, I need to check for the whole word. So it'd be s times w because like you have to check for the whole thing being a match.
Okay. 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 So basically, I would go through the words and like have like a kind of like a fixed like sliding window and check each of those positions inside string inside the string.
Mm-hmm.
Okay. So like wait, so does that make like sense? Like what I said? Like I would have like a so let's say we're looking at words as it's length two. So I would have like I would have like a sliding window of length two fixed and
Mm-hmm.
check each position and ask to see if that's in there, and then I would update the character.
Yeah.
Uh,
And then if your
yeah,
window is matching, then you just mark every character in the window to bold.
yeah.
Yeah.
Okay, okay, yeah. All right. I think I understand like the main. I guess because I'm running out of time. Should I
Yeah.
start coding now?
Yeah, I'd say start
Uh,
coding and then I'll cut you off if we get too low on time.
okay. So we have a char list, which is I'm gonna initialize it to is equal to false times length of nums. Oh, sorry, not nums. I'm used to nums. Length of string. And then okay, I guess so. For like, I'll be iterating over through I'll be iterating through the words, and then I'll get the length of that and check that substring uh inside the string. So I would say for word and words. Um, right. I would say length word and word. And then I would have like let me see. I'm trying to see how this like window. I have a left of. I would initialize a left right of zero and a right of length word minus one. And then I'd iterate through So for I'll do the string. Let's see for okay. I use like actually I use a while r is less than okay less than less than that's greater than r is less than length of string. We'll check if um if like let's see if the word um if string if s starting from index l to r plus one. It should be yeah. If it's small plus one, it's in words, and then I would do um, char to r plus one is equal to true. Actually, no, that doesn't work. Um, what's the? Let me see. I guess I could just do like another like loop. So for in range char char would be L to actually be L to R. Be L to R plus one range. So it'll be char dot I is equal to true. And then if it's not in words, we just update the pointers. Then I'll be L called plus one, and then R plus equal to one. And we check that, that'll finish. And then let's see. So after this, all of the like the char table should be done, or the char list should be completed. And then I would have to like I guess iterate over let me see. I have to iterate over, let me go back to what it said. Should I close purple tag? We're giving a string tag. Wait, what is that?
Yeah, so basically everything that's marked true should be under bold tags, and then things that are right next to each other should be combined. So
Okay. So everything is true. I'm trying to see how I would handle. Okay, so for in range and char if char I equals true. I'm trying to see how I would build this. So say res so it'll be res equals to res plus equals res equals res plus let me see. I use this interesting. uh, res equals res plus good char. Wait, how do I get the char?
So the char is in the string, so you can just put it between the tags. But so let's just talk from here without the coding, so it'll be a little bit faster because we are running low on time. So basically, you need to have a bold tag and then like the character and then another bold tag, right? So you can do like string plus character plus bold tag. But the problem
Yeah,
with this is things that are so if I have like this, all the trues together need to be in one bold tag. So without coding,
yeah,
how would you change this? Because right now you're just like your thing would put every character in a bold tag, and the whole point of this was to get uh, something where now we know like we can easily get things that are right next to each other, right? So how would you change your code to without coding to do this? So I would basically want something like this, right? In this case, and then the true will be the real character, and then the false will be the real character.
uh,
But
okay, so I guess I'd have probably like like a while loop then, like while the character is not while the character wait. So I guess I would check if the first like if char is equal to true.
mhm.
I say like while that next like that next index is equal to true. So like, I guess while it's not equal to true, then I would put that ending tag there. That makes sense.
While it's not equal to true. Oh, I see. Okay, so you basically say that you're like while it's true, keep putting the character, and then when it's not, then add the ending tag.
Yeah.
Okay, yeah, I think that makes sense. So one last question, then we can move on, and I'll give you a few more minutes for the second problem, just so we can go a little bit over, just so you don't run out of time. So you did this like on line 80. You did this like res plus. Now imagine if I have something like this. Okay, so basically I am, or even just like false, right? Whatever, doesn't matter. So you're basically going to be adding one character at a time here. Let's say this is like a million characters. Um, do you know the time complexity of res plus? Like if I just do, like a plus b and then do some ab plus c. Do you know the time complexity of adding a character to a string when the string gets big?
So you have to iterate through the whole string.
Like
It's
I guess what's the time complexity of this, right? If I have like 1 million character string plus c.
that would be of n.
And why is that open?
I'm saying it's of n because we'd have to iterate through like we have to like copy like all the res again and then the add that
Yeah.
whatever
So
character we're
is
adding.
there so how could you have rewritten this to where even if our strings get really big, this character addition is not super costly?
Um, that I'm not too sure. Let me see. Uh,
Because we need a string at the end, but like until the
I
end, we
guess.
can have
Oh
whatever we
yeah.
want.
Okay. I guess we could use like a listen and join it at the end, like dot
Yeah.
append listen and join it at the end.
Yeah. Okay. Because yeah, like basically a million linked list plus C or append C is cheap, is O1. So yeah. Okay.
Yeah.
All right. Let's move on to the next. Let me
Okay.
just comment this out. Okay. All right. Give you some examples. Okay. And I will give you 25 minutes or 20 minutes for this one, just because you're a
Okay.
little bit over. But this one's a little bit less time as well. So.
Okay. Let me read this question. Uh. All right. Play it again. quantum speed. Okay. Um, Let me read these examples to you. Okay. It's a long question. Max some questions.
Sure.
Just to get our things. So, I'm given two arrays, distance and speed, and in the distance array, each index represents like how far a monster is.
Mm-hmm. Yeah, so imagine
Okay.
you're at like positions 0 or something. So you can almost think that they are like like imagine like an X plane where like you're at position 0 and then this is at like 1, 3, and 4. So that's how far they are away from you. Yep.
Okay, and the speed is how fast they move, but they all move. I think I saw something in this which said that they all move speed of light monster in kilometers per minute.
Yeah. So
So
to make this simpler, imagine we have, units of distance that are whatever, doesn't really matter. And so they move one like let's say like um your gun recharges in like what did it say, like 1 second, I think.
I think it's like 1 minute or something like that.
Yeah, so whatever, so let's say this is all in terms of minutes. So it's
Yeah.
like, so basically they move every minute, they will move this amount of distance, and then your gun will recharge every minute. So basically, like, the first guy in a minute will be at 0, the second guy in 3 minutes will be at 0, and then the fourth guy in 4 minutes will be at 0. And you don't have to worry too much about like units of measure, like kilometer, mile, whatever. Just think about it in terms of like distance has no like kilometer or whatever, anything. It's just like 1 unit, and then
Yeah.
speed is 1 unit per minute, and then your gun recharges once a minute.
Okay. Hmm. Um. Let's see. Yeah, like for me, I'm still trying to like wrap my head around this question. So let me just reiterate that. So our gun charges are like 1 minute per second, and so this speed maps to like the speed of the monster, like in index. So speed of like so speed zero is the speed of monster one, and that's how far it is.
Yes. So basically, like, they start out here. In 1 minute, they will be at here, and so on, right? So they will move. So imagine you're at 0, they move towards 0 at this speed per 1 minute, and then your gun recharges once a minute. So like your gun is like ready here, your gun is also ready here, and then the next one would be like your gun is ready here. So the first one's already there, so it doesn't really go further. Then it's like this, and so on, right?
Okay. And then it wants us to return the maximum number of monsters you can kill before uh you lose, and I lose once a monster reaches. I guess what did it say? Lose when it reaches your city.
Yeah, so in the example, the X is like the one you killed. So you could see like in the beginning, you'll just kill the one that's at 1. After a minute, the one that's at 3 will be at 2, the one that's at 4 will be at 3. So you'll kill the one at 2, and then you'll kill the one at 2, and none of them reach the city. But in the second example, you can only kill one, and then after 1 minute, the second one reaches the city, so you lose. And they also tell you that, I believe, if it's a tie, I think you can kill it. Or let me see. No, actually, if it's a tie, you lose. Looks like. So that would be an example 2. So in example 2, you kill the first one, and then in 1 minute, the second one already reached the city, and your guns recharged. So your guns recharge right when it reaches the city, so you lose.
Okay. All right. I'm gonna try going through example 3, so just to make sure. I feel like it's not too hard, but I'm just I can
Sure.
grasp everything. Okay, so first index is a monster, and it's 3 units away. The speed of 5. So let's say I can kill the first monster. Just have it right here. I can kill the first monster. It becomes X, and then I have to wait till my gun reloads, and so that means the second monster. Let me see. I'm actually confused.
Mm-hmm.
Uh, it's not clicking. Let's see. Okay. Given that this is the monsters of 324, you eliminate first number. Okay, after a minute, the distance of monsters X02, so you lose when you eliminate one monster. So we kill 3, and then our gun has to wait to so we kill 3, our gun has to reload or whatever. We have to wait till it's ready.
Yeah, so basically you can see in this
I'm trying
second
to see.
example, so the second one is at distance 2, and it's moving at 3 units per minute. So it's going to reach the city in under 1 minute, right? Because it's at 2 and it moves at 3 per minute. So you kill the first one, and then the second one reaches the city in under a minute, and then you lose. And then the third one would have reached the city in 2 minutes, but because the first two will both reach the city in under a minute, you can only kill one, and then you lose no matter which one.
Okay, so excuse me. Okay, so we kill 3, 5 is gone, 3 is gone. And the
Mm-hmm.
second one is 2. Um, so, so it's 2, and we wait a minute. And then because it's 3, it kills. Wait, so we made it. Wait. So I guess this is just like seeing like how far like the speed is compared to like our starting index of 0.
Yeah, basically every minute you just check, is there a monster at my city? And if there is, you lost. So you just every minute you can fire a gun, and if there's a monster at 0, then you lose.
Okay.
So because in this case, this first one would be at the city. Um, imagine this was I'm at 2 miles or whatever, and I'm moving 3 miles a minute. So I'm going to be at my destination in under a minute, right?
Yeah.
And so that's why you can only kill one, because the second one will get there before you can reload, and then you lose.
Okay. So basically, what we are comparing is to. Wait, can you please repeat that?
Yeah. So if I'm at 2 miles away from the city, imagine you are always at position 0, right? This is where you are
Yeah.
with the gun. The monster is here, 2 miles away from the city, moving 3 miles a minute. So it's going to get there in under a minute, right?
Yeah. Okay.
So you killed that first one, but then the second one is this one, which will kill you um, before you can shoot again. So basically, it's like every minute, shoot my gun, but if there is a monster where I am, I lose. And then, like, what's the most I can kill?
Okay.
Yeah.
Okay. All right. So I guess so. Right now, I'm trying to think of like the condition of when you see like when like when you lose, and that's like I'm thinking that condition would be when
Yeah,
like
so the condition that you
the
lose is right
speed
here.
is.
Like, if there's a monster where I am, at the time I need to shoot, then I lose.
Yeah, I guess I was trying to put that into like like I guess like coding terms in my mind and how
Okay.
to um so like if like so I guess one thing I thought about is like if the speed so if the speed is greater than the current it's called distance, then it would reach us before like it would reach like I would lose basically.
Sure.
Okay, like so, so like does it like make sense? Like did I
Well, in this case, so you can kill the first one, right? Like, if this is like 1 and 1, let's say, you kill the first one, and then after a minute you would lose, but you killed one, so that's why I returned one.
yeah. Okay.
So you just kill as many as you can in like a smart way. Um, okay, so we are running a little bit low on time, so I think let's just, instead of going coding, we can just talk about it at high level. So how can I figure out, like, basically, what would be the smart way of killing them? I guess, because like, you don't have to kill them. I guess you didn't ask about this, but
In
you don't have to kill them
order,
in order. Yeah.
right? Okay.
So what would be the smart way of doing it? And you can just talk about
Um,
it.
I guess you should like kill all the slowest things first,
The slowest things first.
as in like 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 sort of like speed.
Okay. So why would
Um,
you want to kill the slowest ones first?
because wouldn't I say slowest? Sorry, I meant fastest. You kill the fastest ones first because like those are the ones that would reach you first.
So you would just like sort by speed or something?
Yeah, I was thinking about sorting it by speed.
So can you see a problem with just using the speed and that's it?
Um, I guess also like if it's like
Hmm.
if it's like if it's like close like if the distance is like already there, then I guess speed doesn't matter.
Well,
Uh,
so let's say I'm like a million miles away and I'm moving really fast, but then there's something that's like 1 mile away and moving kind of slow. You could see how you'd want to kill the one that's 1 mile away because it's going to get there faster. And you can kind of say the other version of that where like, well, I guess that is the other version, right? Where like you're really close but you're moving really slow, or you're really far and you're moving really fast, or there might be some intermediate of that where like, uh, you know, like maybe I'm 10 miles away and I'm moving at like 6 miles a minute, or I'm like 12 or whatever, like I'm 4 miles away and I'm moving at 1 mile a minute. So how can I calculate something else that's a better factor than just like,
I
because
guess like
speed and distance
speed.
both have to do with each other. So is there something I can calculate that's better?
I guess like speed over distance.
And that would give you what?
I'm like I guess like how fast you're moving per I guess mile or kilometer.
So what does speed mean? Like in units?
Oh wait, what do you mean with speed? Like how fast you're going?
So speed is in units, right? Like when I'm saying I'm driving 60 what?
Like miles per hour or like
Yeah, so it
just
gives you
the speed.
distance over time. So we have
Yeah.
distance and speed. So what do we care about the most?
Time.
Yeah, because like we basically want to know how long it takes for the monster to reach the city, not the speed, not the distance. So how would I get that?
So how would you calculate time? Would it just be distance over speed then?
Right. And so if we
Yeah.
had times for each monster to hit like attack the city, then what would be the smart way of killing them?
Um, so if you're doing it by time, I guess like the lowest time as in like
Yeah.
the closest one to like hitting us.
Okay, so imagine we have these like instead of this, we change our input now into like one will take 1 second, one will take two, 3, 10, 3, whatever. Let's say we have these like sorted, so like 3, 3, 3, whatever. So now that we have this kind of input, then just high level, no coding. Then how would you kind of like make this work? How do you figure out like how many you can kill before you get hit?
And these are what's called time, you said?
Time, yeah.
Okay. Um, so you would so you would so you just kill like so I'm trying to calculate time. So like after we kill one, so we lose when they reach us and they reach us. Um, I'm actually not too sure.
Okay, so basically like let's say in 1 second, what will happen is I'll kill the first one, right? Like right away I can kill the first one, and then all these go down by one. So like let's just
Yeah.
make it shorter. So let's just say this is our thing. So this will happen after like 1 second, and then after 2 seconds, I'll kill two of them, and all these go down by one,
I must say okay.
and so on and so on. And then if one of them ever hits a zero before I kill it, then I lose.
Yeah. Okay.
So, but it's not super efficient to just like go and subtract them all by one, right? Every time, because that would be like n squared. So, is there a better
Yeah.
way we can do that? Basically, like we kill one and then we like go to the next and so on, and then we figure out like where we die or if we die, without manually going down by like reducing every number by one.
Um, um, I guess like so instead of reducing it by just like one like over each time, maybe like I don't know, maybe like there's like a total we can add and compare it to like a number, and then if that total of like time reaches a certain number,
Hmm. So, what would
um,
that kind of look like in just like
yeah,
talking about it?
I'm trying to think of like what the number would actually be. Uh, so I guess like um
Yeah,
so
so we
maybe
can
we do
only
like
fire a gun like at every like minute, right? Like our gun's ready in the beginning, then it's ready at like minute one, minute two, minute three, minute four, and so on.
uh, yeah, I blanked. Let me see. Yeah, wait, keep you say that again.
Yeah, so we can
Repeat that.
fire a gun once a minute, right? So our gun's ready at
Yeah.
0, 1, 2, 3, 4. So can we use that to figure out like where we die or if we can kill everything?
Um, so I guess like maybe after each time we kill something, we increment the amount of things we killed, and then if like I'm trying to see like I can have like I can compare like my current time or like current like kills to like the total time and see if like um whenever that total time is Less than, oh, actually, I'm not too sure.
Okay, so basically what you would do is you can just have like a what's my current time. So you could say like I'm at 0. And then I just compare what's my current time to when. So this is like time when monster uh, will reach the city. So I just compare my current time to the time that the monster will reach the city, and if it's ever the same, or if the monster reaches it before I can shoot it, then I lose. So like here, I could say like I can kill this guy, and then I would like add 1, and I could say I'm still smaller, so I can kill this guy. I'd add 1 again, kill this guy, and then here we have 3, so it's the same time, so we lose. So we killed 3.
Okay, so that just to make sure like that bottom number is the total amount like shots you've taken, like kills you've had.
The bottom, yeah, I mean, you could think about it either way. You can use the same variable for like the total amount of shots or what time am I at, right? Basically, like
Okay,
every time I reload or whatever, it's
that's
just
like a
another
minute.
second. So
Okay,
that way, I could just go through all of these and just increment my like kills or whatever, and then just see like can I do it fast enough, and that way I don't have to go and decrement the values.
values. Okay, yeah.
Okay, all right, so we could stop here. I think. Okay, so how do you think you did on this one?
I don't think I did too good, but like as of like from compared to yesterday, I definitely wasn't like as nervous, but I still couldn't like think of like
Solutions?
yeah solutions. Like
Yeah.
I try to like pad like nothing was like popping in
Mhm.
my head. I was trying to like my goal was like to like look through examples and try to pattern match, but no patterns like stuck out to me. I mean, I was
Yeah.
like overcomplicating it. Yeah,
It's definitely dangerous to. I mean, there is some like pattern matching you can do, but it's definitely dangerous to go like super pattern matchy. Like, oh, it's contiguous, so I have to just sliding window. It has to be that or whatever, because it definitely
yeah,
is not always the case. So that's like it's okay to pattern match, but it's yeah, it's not great to like overdo it and just be stuck in like a mindset. So I will say for this first problem, we actually asked a I think something similar for my job, and this was for like senior, and like everyone was failing. And this is Leak Code Medium, by the way. So this is like
yeah,
I'll send you the like the problems. So this is like a tough problem for people, even though it's a medium. And I think that I want to say I really like this as an interview problem because there's a lot of edge cases you have to ask. I think when we did it, actually, we just gave almost no info whatsoever, and then
it's very open
like
ended. Okay,
yeah, I guess I can also say this because the person asking this is like no longer at my company, and so we're probably not going to be asking that anymore. But anyway, um, so yeah, like we made it really vague on purpose to see if people could ask these questions. So important questions here that I would have loved to see, and you did ask some of them. You asked, "Are all the words in the string?" That's important because they might not be. The other one you didn't ask, and this is going to factor in your solution, is can the words be a repeat? And I kind
yeah,
of pointed that out to you. So here, there's like basically a lot of clarifying questions that you should ask. Like, can the words be a repeat? I think the other stuff they give you, I think when we asked this, we didn't even give that either. Like, what happens when they overlap and stuff like that. And it's kind of like on you to see, like, oh, these things can happen. I need to ask how that works. And for this one, there's also a lot of solutions. I think the most optimal one is with a try, but there's like a lot that I feel like would be
yeah,
accepted. So not necessarily be a try. And so this other one with just like brute force checking for strings is also fine. Um, and I had to give you a lot of hints for this one, and I feel like you were still kind of not super sure what it meant. Like when I said like, oh, you can have the characters, you can check for where the word occurs, you can mark all those characters. You were still like a bit unclear. So I basically gave you like the algorithm to solve it, and you were still kind of like okay, but like there's these other things. So that's like not good. I feel like if I give you a big hint and you're still kind of struggling, um, then that's not great. And for this problem, for what it's worth, I think it's fine giving a few hints. But yeah, I definitely feel like your problem solving, like what algorithm to use and how to go from a problem to a like pseudo coded solution is like your area that you're struggling in the most.
yeah,
Once you got it and you it like made sense to you, I think your code was good. Like and you wrote it pretty fast. So but it doesn't really matter if like it takes you like 30 minutes or whatever, or I have to give you because basically I feel like as an interviewer, like if I give you some small hints and you can't pass, then I kind of just say to myself, all right, this is a fail, and I'll give you a big hint. And like
Yeah.
maybe it'll be like a slight fail because I give you a big hint and then you just like crush the code and everything else from here. But that was not the case. So I definitely think you need to work on like the first part, like the problem solving, and I do feel like that's worth the most in a DSA like this kind of interview. I feel like it's like problem solving is worth like 30 to 40%, and then knowledge of DSA is worth like 30, coding is worth like 30, and communication is like 10. And I do think your communication is pretty good, but you also I pointed out like so you're like I'm doing idea A and it's like this, and then all of a sudden you just hop to something else, and then you hop to something else. So there's not like a continuous stream of like it's not very clear of like what you're doing. You're just hopping from like one thing to another, and
Hmm.
you don't have like a very coherent thought process in the problem solving.
Yeah.
um but yeah, I think your coding was fine. We didn't get to the other, obviously, speed, right? Like no matter what format they give you, if you give you one problem with follow-ups or whatever or multiple, you need to work on your speed because you just like will run out of time.
Yeah.
So that, and I do think I purposely asked this question because I know like there's a lot of clarifying questions, and it's like reasonably difficult, but also, it is a Google question or whatever, or like a meta question, like totally reasonable to get asked. There is no complicated algorithms as well. And I did kind of lead you towards like you don't need something super complicated, super optimal. Just like think of something. Um, so I do think this was like a fair one.
Hmm.
And then yeah, so I think I rated, yeah. So out of five, I'd say your problem solving here would be like a one or a two because I basically gave you like here's an algorithm and you were still kind of unsure. I think your coding. So I gave it a low. Oh, yeah, actually. So your coding, you got the first, and I remember. So you got the first part correct, like this for word and words, all that. But then you really had a hard time of like, okay, now that I have this like character array, how do I actually bold the right things? So you got like half of it, but then the second part was also, and I feel like that's more problem solving than coding. You just weren't sure like what's the algorithm. So I think like
Yeah.
the main thing is focus on is like what algorithm, and then yeah, I kind of pointed out to you like yeah, you can basically just like anytime you find a true, just do a while loop, and then for every true, write it down, and then like close the bold. And I think that is a reasonably big red flag where like you can't do that part because I think like if that's the problem, like just find all contiguous sequence of characters and put a bold around them. Like I do think that's like an easy problem. So when you were struggling with that, that's like a concern. Um, and then let me see. Yeah. So basically, yeah, I said your problem solving was like a one or a two. Your coding was a two. Your DSA, I gave a one because yeah, you basically didn't know where to go. And then your communication was a three. I think your communication's like your best, even though you're like struggling. You're communicating very well. Um, but I don't know what's going through your head. Like maybe you're trying to find like some super optimal solution, and then you're like, if it's not that, I just like won't explore it or something. But it's kind of hard to say what's super optimal. Like what I would go for instead is uh, try to find something that seems reasonable, and then let the interviewer correct you from there because you don't really know, right? Like
Yeah.
you might have like a two to the end solution, and that might be optimal. But if it's not, then your interviewer will kind of like be like, "Can we do something better?" and so on. Okay, so for the second one, you restate the problem in your own words. Yes, you did not ask about edge cases, like what if the monster's like at the city already. You also had a hard time understanding the problem. I feel like that was like there's a lot of words in here which I kind of like, and you have to kind of figure out, okay, what's this? What's the irrelevant noise, and like what's the stuff I really care about? And you had a really hard time like going from a bunch of text to like what's the stuff I really care about. Um, and then let's see, and then yeah, basically I gave you some hints on like just use a time, and then from there you kind of did figure it out, but same kind of thing. You need to figure out like, okay, the thing I really care about is like when does this thing reach the city, and then from there I just want to kill the ones that are like closer first, uh, and then that would make it better. So definitely like yeah, like I would almost like avoid coding and just literally go from a problem to like what is it asking, what are the edge cases, what's my algorithm, and
Okay.
then after that you can work on your coding because I
Okay.
feel like your coding like is pretty decent, but you just like are super unclear like how do I take this and like make a solution. And yeah, and
All
then
right.
let me see. Da-da. Yeah, and I think that was, and I was like, we're running out of time, so let's talk about a high level. I do think like the second problem I'd say is like a little bit easier than the first, and I do think this is like a fair two problem question for like 50 minutes. So I definitely would recommend, if possible, moving your thing back. If possible, obviously there's like risks there, but I think currently where you are, there's not a great chance you're going to pass. So I would try to recommend doing that. I mean, obviously up to you.
Yeah.
Because there were a lot of like, if it was like one or two things, I'd be like, just study a little bit more. But I don't know if you can get to where you need to be in like 3 days. Uh, so yeah, so hopefully that makes sense, and like you kind of agree with me. I know it's like a little bit harsh, but
You
that's what
know,
I would
it's fair.
recommend.
Yeah. Yeah. I have a question.
Sure.
So like with like I know like my biggest issue is like I guess like problem solving. Just
Hmm.
which basically like the whole thing. Like, is that just like a is it like a reps thing, as in like I guess how many like questions you do, or
Yeah,
like
I definitely think it's a reps thing. So it's like learn the concepts and then do enough questions. Because I think, I don't know how many you've done, but people that are like, I did like 30 and have a Google interview, I almost don't have to interview them. Like, I know they're almost always going to fail. Like, yeah, sure,
yeah
if they're like an anomaly, but like, it's almost always like, if you've done this many, then you have a good chance, unless you're not getting it. Like, yeah, if you've done like 700 and you're still like slow, then you have a problem. But, if you just haven't done a lot, it's a reps thing for sure.
yeah. I'm like I haven't done a lot, but I also haven't done like less. I've done like around like 100 problems, and
Yeah, I'd
like
probably recommend a good number for, also Google's like one of the tougher is like a couple hundred. And also don't try to memorize solutions, learn the concepts, and don't try to pattern
yeah.
match too hard. Like think, Uh because the pattern matching thing can really lead you in like a rabbit hole, I feel like.
Okay.
So try to think, and then yeah, basically I mean, at the end of the day, if you did 2,000, even if you like were a slow learner, you'd be a lot better. So it's like
Yeah,
some
definitely.
people have to do more because it takes them more time. Some people have to do less because they're way better. So find whatever you need and do that.
Okay. Yeah.
Okay, cool. All
All
right,
right.
and yeah, let me know how it goes if you want, and I will send you these links and stuff. So hopefully this is
All right.
helpful.
Thank you. Yeah.
Okay.
Thank you so much.
Yep. See ya.
See ya.